KCC. We are recording. Be on your best behavior. Yeah. Okay, the quiz is on Monday. What video? Oh yeah. Huh? I don't know how it came out though. Actually, there's like 3 of them. No, there's like 3 videos. Oh, yeah.
How'd you do on the quiz?
Hey,
Like the ones about like what were the things?
I don't have any. Okay, you guys are gonna have to tell me the problem because I don't have any sheets. Love, 1D.
Yeah, wait, I was confused.
Obviously.
1D, I was confused. I didn't do it with the part. I did it with the part.
10. 180 minus arctan 3/4. Come on!
Worse than the whole
Come on! I'm not gonna congratulate you on things you're supposed to do. Like maybe, Mr. Park, I finished the first 4 worksheets.
Oh, yeah.
Maybe if you said something like that, I'd say, oh, right. Anyway, to convert to rectangular, the easiest thing to do is use the formula. X equals R cosine theta. Remember, this is just an angle measurement, right? Y equals R sine theta. And then, this is like last chapter's one, right? Okay, I'll do one of them. Which one you want me to do? This cosine or the sine? Okay. So, what's the identity for cosine gorilla minus banana? Cosine of the first, cosine of the second, plus sine of the first, sine of the second. We did way harder problems than that. And then sine of pi, isn't sine of pi 0? So this is just gone. And cosine of pi is -1, right? How do I figure out this? Draw the triangle. Arc tangent 3/4, opposite over adjacent 5. So cosine of this angle is 4/5. So what is 10 times -1 times 4/5? -8. No crinkling though. I heard crinkling. And everybody got C because I don't see C up there. Oh, now I do. Okay, I believe it was 415 degrees, right?
Yeah.
Okay, so X equals R cosine theta. Y equals R sine theta. And then you compute these two by either half angle or you can go like 45 minus 30 or 60 minus 45. You know, you use the sum or difference identities. Or, remember I told you guys to memorize these? Of course, math team people we know, right? Cosine 15 degrees, √6 plus √2 over 4. Okay, but most of us don't remember, so which one you want me to do, the first or the second? The first one. So cosine of 15 degrees, you can write that as 45 minus 30 degrees, right? And then you use the identity. Cosine of the first, cosine of the second, plus sine of the first, sine of the second. I would think most people rather do this than half angle, yeah? Well, it's up to you, it doesn't matter. Yes?
If we did the half angle, can we leave it in this form? Or
No, you gotta simplify it. Okay, I'll do both then. So cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 45 degrees is root 2 over 2. Sine of 30 degrees is 1/2. And so you have 4 times root 6 plus root 2 over 4, like I told you. But the 4's cancel out, and you just get root 6 plus root 2. So that's if you use a sum or difference identity. But what if you use half angle? Like what if you said this one here? Let's go down here. Cosine of 15 degrees, that's the same thing as 30 over 2. So that's going to be the square root of 1 plus cosine of 30, which is root 3 over 2, all over 2. But you can't leave it like that. You've got to simplify it full. Multiply top and bottom by 2. So that's 2 plus root 3 over 4. But the 4 comes out of the radical as a 2, which cancels into the 4. So you're going to get 2 root 2 plus root 3. Yeah, same thing. You can check it on the calculator.
Oh.
I don't care which way you do it. They're both the same. What if you had no calculator? How would you prove that they're the same? Huh? No. Square that. Put in square that, and they come out to the same thing. Both.
Can they be negatives actually?
Where do?
Square them both.
One of them could be negative? Okay, look at these numbers. Is it possible for this number to be negative?
Never mind.
No. Is it possible for this number to be negative? No. Yes, there you go. Yes, if one was negative and one was positive, it would be pretty dumb to square both of them and prove they're equal out. Okay. Anyway, you have. We're not gonna. People, we don't have time to go over. You guys don't. You guys know how long today's lecture is. And if you don't get today's lecture, you're doomed. Okay, next, number 3. Okay, so on the quiz, I'll tell you what's going to happen. You're going to have one problem from number 1, one problem from number 2, number 3 is on there, and they're going to have 2 problems from number 4.
Isn't it just the whole thing?
No, selected problem.
Yeah, but
Okay, number 3. I gave you a hint! And believe me, there will be no hint on Monday. Find the distance between 380 degrees and 200 degrees. Okay, there's 2 ways to do this problem. One is to convert this into rectangular coordinates and then use the regular distance formula. How many people tried that? That was just futile, right? Nobody even tried that? Or the other way is just draw the picture. How do you graph 380 degrees? You measure off an 80-degree angle and you go 3 units from the origin. Haga! That's 3. How do you plot this point? Measure off a 200-degree angle and go 5 units from the origin. Waka!
yeah, that's it.
So find the distance between those 2 points. Let's call it x. If you know 2 sides of a triangle and you want to find the 3rd side, what else do I need to know? The angle included. And do we know that angle?
Yes.
Yes, it's 120 degrees. 200 minus 80, right? So if you know 2 sides and the included angle, how do you find that 3rd side?
No.
Law of cosine. Now, I'm not going to give you the formula like on the test. You better know the law.
You're gonna give us a hint though.
No, there's no hint. Yeah, on the first time you do it. Here, you just got to remember, if you want to find the distance between 2 polar points, use the law of cosines. X squared equals 5 squared plus 3 squared minus 2, 5, 3, cosine of 120 degrees. And you guys can take the ball and run, yeah? Comes out to 7. See how nice they made it come out? If you don't get 7, then my guess is you probably computed this wrong, or you put a plus sign there, or you forgot 2. That's my guess. Those are the common mistakes. And then 4. Going to have 2 of these on the quiz. Okay, 4 M F J. Thank you for putting it in order. F. What's F? Come on!
That's what it is.
R equal root 2 over sine theta plus pi over 4. Come on! Okay, what should you do? Rhymes and Haas multiply.
Cross multiply.
Next year, you think your teacher is going to say it rhymes with this, it rhymes with that? I don't think so. Okay, look, there's only one thing you can do. Expand this. Sine of the first.
Cosine of the second.
Okay, cosine of the second plus cosine of the first, sine of the second. Now, what happens when you distributize the r? R cos, here, I'll just write it out. R sine theta, hey, you somebody, yeah? And then if you distribute the r here, r cosine theta, hey, you somebody, yeah? So that's x, this is y, and then if you multiply both sides by root 2, you get x plus y equal 2, and that's a line. Everybody can graph that line. X-intercept 2, y-intercept 2, shing! Or shing! Oh, so Mr. Park, the key is you gotta know the identities. Duh. J. R equals 2 cos theta plus 2 sine theta. Did I remember it? Yes. Okay, this is kind of like the one we did yesterday on the board, except I didn't give you this, but it's the same principle. What are you going to do to both sides? No, multiply both sides. R. No, R means you go this. R to that equals R to that. That's R'ing it. Multiply both sides by R. So R squared is equal to 2R cos theta plus 2R sine theta. You somebody, you somebody, you somebody. X squared plus Y squared equals 2X plus 2Y. How do I put this into standard form? You complete the square. You put the X's together, leave a space. Put the Y's together, leave a space. Throw the number on this side. What do I have to add here and here to make a perfect square? Rhymes with hun and bahun.
1 and 1.
1 and 1. So if you add 2 on the left, you better add 2 on the right. So x minus 1 squared plus y minus 1 squared equal 2. So the center of the circle is at 1, 1, and the radius is root 2. So, something like that. That's ugly. Anyway, you know that last year I think I put this problem up because I remember. Your graph, your circle better pass through Oregon over here. Because if it doesn't pass through Oregon, the radius is not root 2. No, I just remembered that now. So a lot of people have minus 1. Because, right, if the radius is 1 and 1, isn't that root 2? So I would say half the class, their graph didn't go through Oregon, so minus 1. But what's the probability? Okay, we'll put the same problem again.
0.
No, not 0. And then M, come on! I showed you the ellipse yesterday and we failed at the hyperbola, is that it? Wait a minute, this is an ellipse! You guys got the hyperbola! You guys got L. You really, everybody knows how to graph the hyperbola then?
No.
Then we better do, okay, if I were you, I would erase M and do L. Because we don't have time to do both. Pick one right now.
L.
Then how come it's not up there then? Look, M is almost exactly like the one I did yesterday. Almost exact. You guys are not even paying attention in class. That's what's happening. Okay, how do I change this to a rectangular equation? What's the first step? This is almost like... Okay, here, put your mind at ease. One of these is going to be on Monday's quiz. Okay, it's either going to be a parabola, ellipse, or hyperbola. One of the last three. That's going to be one of them. And then the other one is going to be from the other ones. Okay, cross multiply. 2r minus r cosine theta equals 6. Hey, you somebody.
Yes.
We did this last time. Okay, so what is it then?
1, 3 over.
Well, thank you for reading it out then.
3 over 1 plus 2 sine theta.
Okay, cross multiply. R equals 2, r plus 2r sine theta equals 3. Hey, you somebody. That's y. Isolate the r's. This is almost just like yesterday. Isolate the r.
Square.
Square both sides.
Square.
R squared equals 9 minus 12y plus 4y squared. But you somebody! That's a hyperbola! Let's put this in standard form. Put all the x's together. Put all the y's together, so that's minus 3y squared plus 12y. Leave the number on this side. Come on, last year Mr. Rubash told me you guys completed the square plenty of times. That's not 2, it's 12. I told you in the afternoon when the sun comes in, you gotta tilt your head to see it. Okay, factor out a okay, this is where everybody goes haywire every single year. If you factor out a -3, what's gonna be left? Y squared minus 4y
Plus 4.
Okay, just leave a space there.
Plus
What do I have to add to make a perfect square? 4. But you actually added -12.
-12.
So this is what you got. X squared minus 3, y minus 2 squared equal -3. Now this side we need to be 1, right? So what? Add 4 to both sides.
No.
No, you divide by -3, which means this one comes first. Y minus 2 squared over 1 minus x squared over 3 is equal to 1.
Why would you put it over 1 if you already...
Because you guys don't know stuff. You guys are babies.
Thank you.
Okay, now how do you graph hyperbolas? Where's the center? Is it 2, 0 or 0, 2?
0.
It's 0, 2. How much do I go left and right?
3.
Radical 3, which is 1.7 about. So go 1.7 left and 1.7 right. How much do I go up and down? 1 and 1. Now what do I do with that? You draw
Box
the
points,
box.
Box points.
Now what do you do with this box? You draw in the rhymes with diagonals.
Diagonals. Diagonals.
And does this hyperbola open left and right? Or is it up and down?
Left and right.
It's up and down,
Up and down.
because the y comes first.
Oh.
There.
How do you know?
Wait, why did the y go
Yeah,
first?
Oh,
When you
'cause
divide
mine
it?
Because you gotta divide by -3.
So if you divide by negative, the y goes first.
No, because y is negative now, and when you divide it by negative, and then it becomes
Plus the
positive.
positive one.
The positive one comes first, and the negative one goes
What if
second.
they're both positive?
Then it's an ellipse.
Hey, do we get to use our calculator?
No, look how nice the numbers came out.
Oh, we don't need to use our
And if they're both negative, then it's
If they're both negative, it's still an ellipse. Well, hopefully the other side would be negative also, because if both of them are negative here and you got it equal positive on that side, then there's no graph, which I wouldn't give you. Okay, we gotta learn. I thought we were gonna finish early today. No way, Jose.
Still like 26.
Yeah, but today's lesson is long. Okay, now what is the technique of graphing I taught you yesterday? You change it to a rectangular equation, and hopefully you know how to graph that, right? But those are just a nightmare, yeah? Okay, the other technique is, it's not really a technique, but in calculus, there's certain equations you just gotta know what the graph is. You just have to. Okay? Just like in the rectangular coordinate system. If you don't know what base graphs are like that, or that, or that, or that, right? These are base graphs. If you don't know what these graphs look like, you're doomed. So same thing in the polar coordinate system. There are certain graphs that come up all the time, and you have to know what they are just by looking at them. Okay, now they're in the notes. Okay, just follow your notes. Okay, first one. R equals a number cosine theta, or R equals a number sine theta. These are circles. In fact, you changed them. In fact, last night's homework, you had problems like this where you had to convert it into rectangular, right? But that takes kind of long. Okay, take out your calculator. Now, do you know your calculator can graph polar?
Yeah.
Yeah.
That's what you said now.
Here, use the graph.
Your graph can, look, there's 4, okay, press the mode button.
Mode.
There are 4 modes. You got func, that graphs functions. What's the next one? Parametric equations, which we'll be learning in the 3rd quarter. Pole, which you can guess is polar. And then sequences, which we'll be learning in the 3rd quarter as well. Okay. Press the mode button. Okay, if you have a prism, I have no idea. I would guess graph, huh? No. Oh. Okay, wait. How does the prism work? You gotta be able to graph polar.
Whoa.
Anybody figured it out? Who has prism?
Worse.
Oh, Matt. About the R. Because you know the button is usually X. That's why.
Wait. Check. Go to the graph screen. Go to the graph screen. Check type. Press type. Type. No, type.
I know it's so close.
There, right there. You press type and then get R equal. Look. There, R equal. There we go. Woo! You guys got it?
Where's type?
Graph screen and then type. Okay, who's having problems with Prism?
This your part.
Yes.
Let's figure something out. This is why you have the formula.
Yeah.
That's why there's X, T.
Okay, people, we're running out of time and you're gonna be on your own. And oh my goodness. We cannot even punch this in, we're in trouble. Okay, so now we're in polar mode. Okay, on the TI calculator, press the Y equal button, and you got R1 equal, R2 equal. You can graph 6 polar functions at one time. I'll be happy if you just do one. Okay? So punch in R1 equal, okay, let's go 3 cosine theta. How do I get the theta? You press the independent variable button, x, t, theta, n. See, if you're in function mode, the x comes out. If you're in parametric mode, the t comes out. If you're in polar mode, the theta comes out. If you're in sequence mode, the n comes out. That's your independent variable button. But on the Prism, you just go to type and they have all the different types there, so you don't have to worry. So punch this in. Okay, now, I don't know if you're in degree mode or radian mode, but you better be in radian mode now. Actually, you don't have to be, but let's just put it in radian mode. And how do I set everything back to the default settings I told you before? Zoom standard, zoom 6 on the TI. If you're at the Prism, just make sure you're in radian mode.
It looks bad.
Okay, so you press the graph button now. Oh, that doesn't really look like a circle, Mr. Park. That's because zoom standard goes from -10 to 10 on the X and -10 to 10 on the Y. There's more pixels this way than this way. So if you want to see what it really looks like, why don't we go zoom decimal?
Yes.
But you have to go zoom standard first to put all the settings back to the default settings. There you go, now it looks like a circle. Did I say anything about zoom square? I said zoom standard, fool. What? You're making Marcy spit. Anyway. Okay, right now, okay, press the window button. This is the default settings. What does the window button say?
2 pi.
0 to 2 pi, and what is theta step?
0.308.
0.13. You know what that is?
1/10? 1/20th?
That's pi
1/30th.
over
1/30th.
pi over
30th.
24.
Wait, mine says
Wait.
7.5.
No, 30. It's over 30.
You're in degree
No,
mode.
I'm not.
Yes, you are. Okay, and if you're not, then you didn't do zoom standard first. You have to go zoom standard because the calculator goes to the default settings.
What's going on?
Okay, just do this. Press zoom. Are you in radian mode?
Yeah.
Okay, press zoom 6. Now,
Okay, got it.
okay, now go zoom decimal. But if you don't go zoom standard first, you don't go to the default settings. See, if you're in degree mode, what happens is your calculator plots a point every 7.5 degrees. That's why hers said 7.5. But she's in radian mode, and it didn't change because she didn't do the zoom 6, so it's plotting a point every 7.5 radians. Which is a lot, because 1 radian is 57.3 degrees, which you don't want that to happen. Okay, so you can see your calculator can graph it, but you have to graph this quickly without the calculator. So what I'm going to give you now, in 20 minutes, is I'm going to give you all the shortcuts for graphing. Okay, when you have an equation of this form, you guys know it's a circle, right? So what you do is you just plot 2 points, one at 0 and one at 90 degrees, boom, you got the circle. Okay, plug in 0.
3.
So 3, right there. Now plug in 90 degrees, or pi over 2. You get 0. You see these 2 points? That's the endpoints of the diameter. There you go. But you have to see, the thing is, you have to know that this is going to be a circle. You know what I'm talking about? And let me show you. Okay, your calculator graphs from 0 to 2 pi now. So this is what your calculator did. I don't know if you guys noticed this, but wow. So you could actually graph this whole circle just from 0 to pi. But your calculator automatically just goes from 0 to 2 pi. So it goes around twice. Did you guys see that?
Yeah.
Okay, good. Because in calculus, it's not enough to know what the graph looks like. You got a graph. You have to know how it's being graphed. Okay, question.
When we take the SAT, do we have to know like how high it goes?
SAT doesn't have any trigonometry on it.
No, the SAT.
Yeah, but they don't have polar.
Okay.
No. Okay, next one. What is the limosons? Limousin. This is a French word. What is that thing called? Yeah, I don't know what it's called, but it's limousin. Because some people call it limacon. That's wrong. Anyway, what is the equation of a limousin? R equal A plus or minus B cosine theta. R equal A plus or minus B sine theta. I guess there should be a plus or minus in front of the A. Why don't we just put plus? Because A or B could be positive or negative. Okay. Now there are three kinds of limosons. Okay. The first one is when the absolute value of A equals the absolute value of B, like this: 2 plus 2 sine theta. Okay, graph this on your calculator quickly. Press the Y equal button. Keep everything the same. And since we're in Zoom decimal, press graph. What?
It's an upside down.
It's an upside down.
Looks like a van.
It's a butt.
It's called a cardioid. Because it looks like a heart, not a butt. It's a cardioid, not a buttioid.
Sorry, I can't look.
Okay, now, you have to be able to graph these quickly without your calculator though. So the secret, it's not a secret, but to graph limosons quickly, you just plot the 4 quadrantal angles. Here we go, 0.
2.
Okay, if you cannot plug in quadrantal angles, you're going to be in trouble. 2. Pi over 2.
4.
4.
2.
2.
2. Now remember, you got to go in the direction of that angle now. You got to graph polar coordinates. So at pi, you have to go 2 units in that direction now. 3 pi over 2.
0.
Okay, so there. So you can see the butt is blowing south. It's facing south. Or whatever you want to call it. That thing is facing south. Okay, well, what would happen if the absolute value of the first number is less than the absolute value of the second number? Okay, graph that on your calculator quick.
1 minus 3 cosine theta.
Oh, that's so cool.
It's like
circle and circle.
Well, basically it's a cardioid, but then it has a loop inside it. So that's why we call this the inner loop. Inner loop. Inner loop. Cardioid inner loop. Okay, now again, plot the 4 quadrantal angles. Go. 0.
Negative.
Negative 2, so you gotta go 2 units in the opposite direction. Pi over 2. 1. Pi.
Negative.
No. Pi.
0.
4. So you gotta go 4 units in that direction now. 3 pi over 2. 1. No, 1. Cosine of 3 pi over 2 is 0. 1 minus 0 is 1. You go 1 unit in that direction. And an additional point will be the origin also. By the way, another name for the origin is the pole. So you kind of have the cardioid like this, but then there's a loop inside it. Anyway, if you just plot the 4 quadrantal angles, the positioning of the 4 points will tell you what the graph is, so you don't even have to memorize anything. Come on. And then finally, the third type of limousin is what happens when the absolute value of the first number is greater than the absolute value of the second number, like this. Yeah, what the heck, let's put a minus there. Okay, graph this on your calculator. What does it look like?
What the hell?
Blob.
Yeah, it's a blob, very good. It's a blob, or some people call it manapoa. No, doesn't it look like a mana? What the heck are you doing? Did you type it in exactly as it said?
Oh, I put 2 thetas in.
Oh. It should look like a manapoa because one end is kind of flat, right? You guys know what manapoa is? One end?
That's what you got.
Okay, plot the 4 quadrantal angles. Go, 0, 2, pi over 2,
I put 3 in.
1,
I put 3 in.
Okay.
pi,
No, put like 5 in.
2, 3 pi over 2,
This gets more.
Yeah, I know, it gets
3. You gotta go 3 units in that direction. What are you doing? You guys better pay attention.
Look at this.
So, it's a manapoa.
Is there like multiple thetas into this?
And by the way, notice, and you guys are seeing with your own eyes what the graph looks like. Because every year, there's always students drawing the cardioid like this.
Yeah, I know.
If anybody does this, that's a fatal error. That's not what a cardioid looks
No, it's
like.
more rounded. Bob.
Yeah, it's healthy and robust. That's what it is. Yeah. Okay, now look at the placement of the 4 points. You see the 4 points? If one point is at the origin, that's going to be the cardioid. But if this point is like inside, then that's the inner loop. But if the point is out there, then that's going to be the manapoa. So if you just plot the 4 quadrantal angles, looking at the 4 points, you can tell what it's going to be. Okay, so those are the limasomes. There's 3 kinds of limasomes.
There's some mistake.
We're not there yet, okay? We got to do the Rose curves now. Next, Rose curves. How many? Rose curves. Okay, anytime you have r equal a cosine n theta, or r equal a sine n theta, where n is a positive integer greater than 1, then it's going to be a Rose curve. Okay, so let's look at one. R equal 2 sine 3 theta. I hope this is not the same as the homework, but whatever, even if it is. Okay, graph that quickly. Yeah, it's a flower. It's a rose curve. That's why I call it a rose curve, because it's a flower. Now, do you notice the petals of the rose curve are always equally spaced apart, so they look nice? So you can use that to help you graph.
Is 3 theta the same thing as putting 3 thetas?
No. Yeah, theta plus theta plus theta.
Oh, but then that's...
But then what if you have 100 theta? You don't go theta plus theta plus theta plus theta. Oh my gosh. Okay, so what do we notice? There's 3 petals. What is the length of each petal? 2. That's this number here, but that's a dull, right? Because the biggest sine ever gets is 1. So 1 times 2 is 2. So the biggest r will ever be is 2. So that means the furthest away from the origin you will ever be is 2, which tells you that's the length of the petal, right? Now we know there are going to be 3 petals. They're always going to be equally spaced apart. So they're always going to be 120 degrees apart. The hard part is to figure out where is the first petal. Well, this is where you got to think. Sine reaches its maximum value of 1 when? At pi over 2, right? So when this argument is equal to pi over 2, that's when the tip of the petal is going to occur. Because that's when r will be as large as possible. So if you solve this equation, theta equals pi over 6. So that means at pi over 6, that's where we're going to have a tip of a petal. That's 30 degrees if you didn't know. So this is how I like to draw the rose petals. You make a circle of radius 2, like this. And so 30 degrees, you're going to have 1 petal. The next petal occurs 120 degrees later. And the next petal occurs 120 degrees later, because they all got to be equally spaced apart. And then you see how they look, right? The petals. They're not thin and sickly, right? They are kind of, healthy, kind of like that.
That's all you have to draw.
Yeah, let me look. Yeah. Okay, let's do a cosine one now. R equals 3 sine, no, I said cosine, fool. Cosine 2 theta. Okay, graph that one. How many petals do you think they're going to be?
A lot.
2.
3,
4.
6,
Okay, why don't we graph it and see?
4.
There's 4 petals. Wait, I don't get it,
Oh,
Mr.
there's
Park.
2 higher.
Well, if this number is odd, that's how many petals you're gonna get. But if this number is even, you're gonna get twice as many petals, if it's even. So 4 petals equally spaced apart, what? Each petal is 3 units long. Okay, where does the first petal occur? Well, for cosine reaches its maximum value of 1 when? At 0. So when this argument is equal to 0, that's where you're going to have to tip up the first petal. Divide by 2, theta equals 0. Oh, so Mr. Park, if it's a cosine 1, then it's going to be 0. Yes, but if it's a sine 1, then you got to divide 90 degrees by the coefficient of theta. Yes.
Why
Yes.
is it when you raise the number of thetas to really high, like let's say like 20 theta?
That's because your calculator is only plotting a point every 7.5 degrees.
Oh, okay.
So the resolution is not good. So if you wanted your graph to look like petals, you got to make theta steps smaller. So right now it's 0.13. If you're gonna graph something with lots of petals, then you better make theta step like 0.01 or something. But then your calculator plots more points. It's going to take longer to graph. Anyway, going back to this problem, the first petal is at 0, right there, and then every 90 degrees you're going to get another one because they're all equally spaced apart. Don't worry, if you practice, you'll get good at this.
So as long as you know the number over there.
Yeah, so like, what did Kobe do? What did you put here? 20. So if you put 20, that means it's going to have 40 petals.
So you just do 360 divided by 4.
Forget how.
Yeah, if you have 40 petals, okay, 360 divided by 40, every 9 degrees is going to have 1 petal.
Yeah, so that's all you have to do with that one.
Yeah, but I'm not going to make you graph 40 petals.
Oh no, I'm just saying.
That's all you have to do.
Okay, last one. The lemniscate. Now these are, you cannot forget, you're going to BC Calculus, you cannot forget this, okay? These are all graphs you have to know, and then you got to do the calculus on them. Because when you walk through the door on day 1, everybody assumes you can do all this. Then we're just going to do calculus on it. Like compute, what is the area of one of these petals? Or what's the arc length of one of the petals? Do calculus. I don't have it on the top of my head, but just do calculus. Okay, lemniscate. Lemniscates have these equations. R squared equals A cosine 2 theta. R squared equals A sine 2 theta. So, first of all, it has to be R squared, and you have to have 2 theta. That's what a lemniscate is. Now, what is a lemniscate? Why don't I give you an equation first? R squared equals 9 sine 2 theta. How do I know this is a lemniscate? Because it has the equation. Okay, now try, Mr. Park, how do I graph this on my calculator? Because I don't have R squared. Duh, so you got to solve for R. So on your calculator, you got to go R1 equal square root of 9 sine 2 theta. Woo. And then R2 equals negative square root of 9 sine 2 theta. Right? Because when you square root, there's going to be a plus or minus because of the absolute value, right? But, okay, what does it look like? It looks like a figure 8. And that's what it is. A lemniscate is a figure 8. Okay, might rhyme. You can use whatever you put. Okay, so here. Oh my gosh, we're in trouble. Okay, we know a lemniscate is a figure 8, but how do you figure out where the figure 8 goes? Well, you got to think, just like the rose curve. This is a sine lemniscate. Sine reaches its maximum value of 1 when? At pi over 2. So you set the argument equal to pi over 2. If 2 theta equals pi over 2, theta equals pi over 4. That means that pi over 4, that's when you're going to be, that's when R is going to be as big as possible. So at pi over 4, what happens when you plug in pi over 4? What's 2 times pi over 4?
Pi over 2.
Sine of pi over 2 is 1. 1 times 9 is 9. So if R squared equals 9,
Plus or minus.
R equals plus or minus 3. So at pi over 4, you're going to have R equals plus or minus 3. 3 here, negative 3 there, and a lemniscate is a figure 8, baby. Okay, that one's not that good. It should be a little more healthy than that. You guys see it on your screen, yeah?
Yeah.
When you do the negative thing, it goes to the same thing. Like it graph it goes on top of each other.
You can figure out one and then just like.
I don't know. I don't think so.
I think
I don't think so. Okay, last thing. We got 2 minutes. Okay, now when you graph regular graphs in the rectangular coordinate system, what does this do to the graph? It shifts it 2 to the right. What does this do? Shifts it 1 to the left. So is there like something similar in the polar coordinate system? You bet your bippy there is. Okay, so let's do this. R equal 1 plus cosine theta. What is this? We learned this today. This is a cardioid.
Oh.
You plot the 4 quadrantal angles. So if you plug in 0, you get 2. You plug in pi over 2, you get 1. You plug in pi, you get 0. You plug in 3 pi over 2, you get -1. So you got to practice if you want to get good. And then can you see? The butt is facing west. Okay, now what if I did this? R equal 1 plus cosine, and then I go theta minus pi over 4. Now, what do you think? So if I do this, how is that gonna affect the graph? Is it gonna shift it pi over 4 to the right? No, okay, quick, graph it on your calculator. This one. Who said rotate? Morris. Rotate what?
Positive.
Oh, very good. See, Morris is thinking. Yes, this rotates the graph pi over 4 or 45 degrees counterclockwise because that's the positive direction. So if you graph it on your calculator, you're going to see the same cardioid, but we're going to rotate it pi over 4, 45 degrees counterclockwise, which means now the butt is going to be facing southwest. And is it?
Yeah.
Yeah, so it's spewing things southwest instead of west.
Kind of lopsided. Probably just the way it's getting
You're not punching it in exactly. Again. What's wrong with you?
1 plus cosine of
Theta minus pi over 4. And are you in radian mode?
Except it's minus, you get it that way.
Well, what kind of scheming do you have? Okay, the bell's gonna ring already.
Oh, good.
Okay, wait, let me see tonight's homework. Quick, quick, I might have to delete problems.
delete numbers.
Okay, delete P, Q, and R. Because we're weak. Oh, look, I even told you what it does. It rotates it.
Wait, which R?
P, Q, and R.
Which you already said, so you can't take it back now.
Delete P, Q, and R. We don't have time for it.
review your next one.
So much for finishing early.
Yeah, this is super like.
Polar 2,
How would you?
delete P, Q, R.
Hey, I heard you getting like an 85. Oh, I'm getting it like 9 now. Even Sung is getting it.